Hello friends, myself R.D. Mahajan presenting my video on MCQs on Laplace transform part 2. First example, Laplace of e raised to minus 2t cos h 4t is equals to, we have to select correct option out of that 4, and for that we know that Laplace transform of cos h 4t, as per the standard result, it is s upon s square minus 4 square. We call this as f bar of s, say, with the condition s greater than 4, and therefore by first shifting theorem, as that function is multiplied by e raised to minus 2t, we have Laplace transform of e raised to minus 2t into cos h 4t is equals to f bar of s plus 2. Replacing s by s plus 2, we get it is equals to s plus 2 divided by s plus 2 whole square minus 4 square, with the condition that s greater than 4. This is the required answer. Option C is the correct answer out of that 4. Example second, Laplace of t sin t is equals to. Once again, we have to select the correct option out of that 4, and to find correct answer, we find Laplace of sin t. Again, standard result of Laplace, it is 1 upon a is here 1, s square plus 1 square. 1 square is 1. We call this as f bar of s, say. Then Laplace transform of t sin t, function f of t multiplied by t raised to n, that theorem or that property. As per that, it is minus 1 raised to n. Power n is here 1, therefore minus 1 raised to 1, d by ds of f bar of s, and therefore it is equals to minus 1 raised to 1 is minus 1, d by ds of f bar of s, it is 1 upon s square plus 1. Differentiating as per the standard result, derivative of 1 by x is minus 1 by x square, and therefore that minus 1 upon x square. X means here s square plus 1 bracket square. Applying chain rule, differentiation of s square is 2s, and therefore we get that minus and this minus as plus 2s divided by s square plus 1 whole square as the answer. Option A as the correct option or the answer for that Laplace transform. Therefore, Laplace of t sin t is 2s upon s square plus 1 bracket square. Example number third, Laplace of t cos of 4t is equals to. Again, select the correct option out of that 4, and to find the correct answer, we know that Laplace transform of cos of 4t, standard result of Laplace is s upon s square plus a square, s square plus 4 square, We call this as f bar of s. C. Then Laplace transform of t multiplied by cos of 4t as minus 1 raised to 1 d by ds of f bar of s, and therefore it is equals to minus derivative of that Laplace transform, and that f bar of s is s upon s square plus 4 . It is equals to minus differentiating this by using quotient rule, u by v rule, and therefore as per that it is s square plus 16 derivative of s with respect to s1 minus s into differentiation of s square plus 16 with respect to s, it is 2s, and whole divided by s square plus 16 bracket square, and therefore it is equals to minus s square minus 2s square we get as minus s square plus 16 divided by s square plus 16 whole square. Multiplying by minus inside, we get that result as this become plus s square minus 16 divided by s square plus 16 whole square as the required Laplace transform, and it is option D as the correct option or answer for that problem. Therefore, Laplace of t cos 4t is s square minus 16 divided by s square plus 16 bracket square, option D. Example number 4, Laplace of e raised to minus 3t into t raised to 1 by 2. F of t multiplied by e raised to 80, it is a problem of first shifting theorem. And to obtain the correct option, once again, we find Laplace of that function f of t, t raised to 1 by 2. Here that power n is not a positive integer, therefore its Laplace is, as per standard result, it is gamma n plus 1 divided by s raised to n plus 1, and it is equals to, the value of that n is 1 by 2 here, therefore gamma 1 by 2 plus 1 divided by s raised to 1 by 2 plus 1, we get 3 by 2. We know that gamma n plus 1 is n gamma n, therefore it is 1 by 2 gamma 1 by 2 whole divided by s raised to 3 by 2, and that is equals to 1 by 2. Value of gamma 1 by 2 is root pi divided by s raised to 3 by 2, and we call this as f bar of s. C. Then by first shifting theorem, Laplace transform of t raised to 1 by 2 multiplied by e raised to minus 3t. As it is multiplied by e raised to minus 80, we have to replace s by s plus a is here 3. Therefore, replacing s by s plus 3 in this result, we get its value as 1 by 2 root pi divided by s plus 3 raised to 3 by 2 as the answer or the Laplace of that. Option B is the correct option or the correct answer. Example number 5th, find Laplace of sin t by t. Find the correct option out of that 4. And to find the correct option, we know that Laplace transform of sin t, standard Laplace transform result, a is 1 upon s square plus 1. We call this as f bar of s, say. And then by the property f of t by t, sin t by t, a division by t property, it is integration from s to infinity of f bar of s ds, and it is equals to integration from s to infinity. F bar of s is 1 upon s square plus 1. Its integration is 1 upon 1 plus x square. Its integration standard result is tan inverse of s by a is 1, divided by a is 1, and limit from s to infinity. Substituting the upper and lower limit, upper limit as infinity, lower limit as s, we get tan inverse of infinity minus tan inverse of s. Standard trigonometric result, tan inverse of infinity is pi by 2 minus tan inverse of s, and pi by 2 minus tan inverse theta is, all of you are knowing as, a cot inverse of s. Therefore, it is cot inverse of s as the answer. Option D as the answer for that problem, or the Laplace of sin t by t. Laplace of sin t by t is cot inverse of s. Option D from that. Example number 6, find Laplace of integration from 0 to t of cos t dt. It is f of t and its integration with respect to t between limits 0 to t. Therefore, to find the correct option out of that 4, again we know that Laplace transform of cos t, standard Laplace transform of cos t, is s upon s square plus a square. A is here 1, therefore 1 square is 1. And we call this as f bar of s. Then, by that property, Laplace transform of cos t by t, integration from 0 to t of cos t, standard result or theorem, its Laplace is given by 1 by s into f bar of s, and therefore it is equals to 1 by s f bar of s. Value of f bar of s is s upon s square plus 1. S get cancelled, we get answer as 1 upon s square plus 1 as the Laplace transform of that integration of cos t. Option A is the correct option. Example number 7, find Laplace of e raised to at minus e raised to bt divided by t. It is f of t by t type of function, and therefore to find the correct option, we know that Laplace transform of e raised to at minus e raised to bt, taking individual Laplace of e raised to at is 1 upon s minus a and minus 1 upon s minus b, provided s greater than a and s greater than b. Then Laplace transform of e raised to at minus e raised to bt divided by t, as per that theorem, it is integration from s to infinity. We call this as f bar of s, say, of f bar of s with respect to s, and therefore it is equals to integration from s to infinity f bar of s. F bar of s is 1 upon s minus a minus 1 upon s minus b. Its integration with respect to s. Integrating individually with respect to s, we know that integration of 1 by x is log of x, and therefore it is log of s minus a minus integration of the second term is also log of s minus b, and limits from s to infinity. Log a minus log b, we know that it is log of a by b, and therefore it is log of s minus a divided by s minus b, and limits from s to infinity. And when we substitute the limit, upper limit as infinity, lower limit as s, we have to interchange the terms. Term from numerator goes to denominator, and term from denominator goes to numerator, and therefore it is equals to log of s minus b divided by s minus e as the answer. Option B is the correct answer, or correct option. Example number 8, find Laplace of t e raised to minus t sin t. Here it is a product of three terms. If we consider sin t as f of t, then it is multiplied by t, means theorem by multiplication by t raised to n, and then once again it is multiplied by e raised to minus t. It is a problem of shifting theorem. Therefore, we have to apply that two theorems to obtain that Laplace transform. Therefore, to find the correct option, we go step by step. We know that Laplace transform of sin t as standard result, it is a upon s square plus a square, s square plus 1 square. We call this as f bar of s. Say, then Laplace transform of that sin t multiplied by t, multiplication by t raised to n property, it is minus 1 raised to n, value of n is 1, d by ds of f bar of s. As per that, it is minus 1 raised to 1 is minus 1, sign is minus, d by ds of derivative of that function f bar of s. Function is 1 upon s square plus 1. Derivative of 1 by x is minus 1 by x square, means it is s square plus 1 bracket square, chain rule, as it is function of function, applying chain rule. Differentiation of s square is 2s, and if you simplify it, it becomes 2s divided by s square plus 1 whole square. We call this as a new f bar of s. We call this as a new f bar of s. And then by first shifting theorem, Laplace transform of t sin t, it is multiplied by e raised to minus t, and as that function is multiplied by e raised to minus at type of term, replace s by s plus a is here 1, and therefore it is equals to replacing s by s plus 1 everywhere, we get that result as 2 times s plus 1 whole divided by s plus 1 bracket square plus 1 bracket square as the required answer. 2 times s plus 1 whole divided by s plus 1 bracket square plus 1, and again option A as the right option or correct option or the correct answer. Example number 9. Find Laplace of integration from 0 to t of t sin t with respect to t. If you observe here, it is a combination of two properties or two theorems. Function f of t multiplied by t, therefore we have to apply that first, and then it is integration of that f of t. Therefore applying that two theorems, we know that Laplace transform of sin t, standard Laplace transform result, it is 1 upon s square plus a square, a is 1 square, and we call this as f bar of s a. Then Laplace transform of t multiplied by sin t, f of t multiplied by t raised to n theorem, it is minus 1 raised to n, the value of n is here 1, therefore minus 1 raised to 1, d by ds of f bar of s, and therefore it is minus d by ds of that f bar of s is here 1 upon s square plus 1. Differentiating that 1 by x with respect to x, its derivative is minus 1 upon x square, means it is s square plus 1 bracket square, chain rule. Differentiation of s square with respect to s is 2s, and therefore if you simplify it, we get that value as 2s divided by s square plus 1 whole square, we call as new f bar of s. Okay, and then applying lastly that second property, integration, Laplace of integral, Laplace transform of integration from 0 to t, t sin t dt as 1 by s into f bar of s, and therefore it is equals to 1 by s, f bar of s is 2s divided by s square plus 1 bracket square, and if you simplify it, s's get cancelled, we get that value as 2 divided by s square plus 1 whole square as the required answer. Option B is the right answer or correct option. Example number 10. By Laplace transform technique, find the value of integration from 0 to infinity of e raised to minus 2t sin 4t dt. Therefore, we can evaluate this type of definite integral by using Laplace transform. Therefore, let I as, suppose, integration from 0 to infinity e raised to minus 2t sin of 4t dt. This we can rewrite as integration from 0 to infinity, replacing e raised to minus 2t by e raised to minus st, into sine of 4t dt, and we mention the value of s, where value of s is 2. And then as per the elementary definition of Laplace transform, integration from 0 to infinity of e raised to minus st f of t dt is Laplace transform of that f of t. Here f of t is sine 4t. And then finding the Laplace of sine 4t. Again, standard Laplace of sine 80 is a is here 4 upon s square plus a square 4 square. And then at s is equals to 2, we get that value of integral as 4 upon s square. The value of s is 2, 2 square is 4, 4 square is 16, therefore it is 4 by 20. 16 plus 4 is 20. Dividing by 4, we get that value as 1 by 5. Value of that definite integral by Laplace transform technique is 1 by 5. Correct option is A. Therefore, like this, I have discussed 10 different examples based on the properties of Laplace transform or the theorems on Laplace transform. I will present one more video on MCQs of Laplace transform. If you are watching my videos, please like and share it, as well as subscribe to my channel to get updates for new videos. Thank you very much.